Yeah, hello, I'm Patrick. I want to talk about Arduino and about the new idea in computing which is possible with this open source hardware. It's about physical computing. Well, to start, when you have kids or when you were a kid yourself, ask yourself, how did you actually learn things? And you learn things by grasping things and seeing if it's fitting somehow or if it makes noise and how does it feel. And I think we all know how Lego actually influenced our sense for architecture and for computer architecture a little bit. And we also know that these building blocks are what we do with objects and components, what we try to build nowadays with software. So I think this is an important thing about physical computing. And if we look at more complex ways how we learn stuff in computing nowadays, we make models, we make visualizations. But this project was, in this sense, very special because he made a graph which was a JSON data structure, but he could also print it out as a 3D print. And how does he do this? I think with 3D printers and so on, it's in the context of maker labs, which are popping up nowadays. Munich has 2 or 3 of them. The biggest one is Fab Lab. And yeah, people gather and try to explore how can you make components and how can you make things. And one of the biggest, most important component in physical computing, it's Arduino. I brought one with me. It's blinking right now, so it looks like this. It's an Arduino with a shield, and it has actually only 2 functions. It's a blink, which I will discuss later more in detail, and actually my whole talk will be about blinking. And there's a potentiometer which can modulate the blink frequency, and I didn't solder it to be more flexible. And I can, if you see now it's blinking very fast. And if I pull it up, it blinks very slowly, so it's about fading here. Anyway, with Arduino, other people hacking their cars. This is a project which actually opened up the gearbox of a Porsche Cayenne, and he found out how to enter automatically the sports mode with the Arduino. And what I think is also very promising, and this brings us why I'm talking tonight here in the Node.js meetup. It's Arduino, it's also providing a new way to enter and interact with web browsers. And imagine that you can buy this one here. It's just like 10 euros on eBay. And you can hack it, and you can then control your Arduino with it. And you can hook it up into the browser with sockets, which I wanted to demonstrate, but it's hardware, so I'll keep it maybe after the break. Let's come to a more simpler setting. It's the blinking example, and it's also a very fun thing because we react to repeating signals. And I found funny this article discusses how can you make your robot human-like, and blinking is on the #1 thing. So if you want to build robots, it's also a good thing to understand a little bit about blinking. Okay, let's come now a bit more to the technical part. Arduino 101. Arduino, it's this board. So it's more than a microprocessor. It has a microprocessor, but the nice thing on the Arduino is that it has these pins and this layout of the board. And this was standardized on the Arduino UNO, which is the most popular one. There are other models, smaller ones, which I brought with me too. So this is Arduino Nano. It's only 2 or 3 euros, so you can buy plenty of them and put them everywhere. And there are even clones which which are not named Arduino. But it says they have their clones, so they're even cheaper, and they can also be fun to explore. But there you don't know exactly. You need to hack more to find out how they work. So Arduino UNO, what makes it different from Raspberry Pi or other kind of open source projects is we got some analog pins. So especially if you work with sensors like temperature, sound, light, you need to work with analog signals. And we can here take inputs from our environment, and we can feed them here as outputs, as digital signals. This is one of the main functions. We can also take inputs via the digital pins and put them to other sensors via protocols and make outputs from digital pins here. How does a typical project look like? It's all open source, so you can download it, and you will get this kind of IDE. It's processing, and the project you call it is called a sketch, and then you do first some setups, and then you do the coding of your idea. So this blinking, for example, you switch on the pin high, you wait a little bit, and you switch it off. I take this as a starting point because this is C, and C it's very much different from JavaScript in that respect that it's blocking, and it's not so fun with working with blocking code. So this is again the code, more clear. So if you want to make a real fun interaction and you have only the blink would block your code, but you want also to fetch things from the network or take something from other sensors, you would need to handle all this in your loop. So it's for prototyping, and we all know from JavaScript that we can let things run and let them do stuff, and we can pick them up later with a callback and react to this. So for me, JavaScript feels like a very interesting place to explore Arduino programming. And I also found this quote very funny because JavaScript was invented to do exactly this kind of thing. It was, we have a mouse in the browser and we want to make a monkey dance, and it's I think a good fit. So how would we work with JavaScript for doing this kind of things? That's the question maybe to think. What is one of the first JavaScript functions you ever used when you were doing some blinky stuff in the browser? I think it's maybe this one. Another way to write a blink is this one. It looks simple, but we need actually somehow the JavaScript. It's quite a high-level language, and the Arduino is a microprocessor, and it does actually some byte shuffling and push signals in and out. So how can we go from the high-level JavaScript language to low-level thing? And there are several libraries who support this, and the Johnny 5 it's one example, and it provides us then with a basic language to work. Actually, let me think. I had some videos, but okay. It's here already. So, because I wanted to show it with live coding, how you do JavaScript demo, but as live demos are not so nice with hardware, I took a recording yesterday, so I think it's Johnny 5 demo. Yeah. So the LED is over there, and here it's a control. So when we run 25, we start it up. We have we can work with it in a REPL fashion, read, eval, print loop, which is also very nice because you don't need to actually compile the code and upload it to the device. You can just interact interactively with it. So, that was it. It was a short demo. But we got one problem because Arduino, it's, as I said, it's a board which is very basic, low level, and we need to find some way to speak to the Arduino. And the way to do this, it's with Firmata. Firmata is some kind of a level, abstraction level above the serial port. So you got, in the serial port, you got 2 lines, one for sending, one for receiving. And Firmata gives you an easy abstraction to speak with the serial port from the outside. And there are libraries which can speak Firmata. And then it's also available in Python and Ruby and JavaScript. And this is the entry point then to work with JavaScript. But now we come back to the processing IDE because the Firmata, it's a sketch which the Arduino needs to understand first. So you compile it. I can show, maybe I have an Arduino, another one. Yeah. So this is our sketches, and there are here basic sketches, and this is the Firmata protocol which we need to upload first. So I open it, and we can see from the code, it's basically giving all kinds of API functions, and we compile it. Then I select my Arduino and I can upload it. So, and from now on we could speak here. Let's see what I have. I have here a small script. Yeah, we say when we get the ready event from the board, we actually address the LED and then we switch it on and off, and yeah, and we switch it on again. And if we would do this, it looks like the following. Yeah, now we have got the rebel, and I think I have the LED here. No. Anyway, you saw this earlier, you can then work with the REPL. So let's see, then we go to, yeah. It's also nice to, when your Arduino is not behaving as expected, you can work with this Firmata test program, and you get then all the signals from the board, and you can play directly with the signals. So this is a nice side effect of Firmata. And again, how it works: you've got JavaScript, you speak with Firmata serial port, and the Arduino then just reacts as a client or slave. Yeah. So this is, as we see, all connected with wires, and this not, because it's running on a power pack and it has the embedded code, so it doesn't need to have a connection. But as long as we work with Firmata, we need one. So there are other Arduino boards. One example is the UNO, and it's a networked board. It has Wi-Fi, and we can directly speak with it. You also need power for this one. I won't do the live demonstration, but maybe after the break. But this would how it would look like. So you can go with the web browser to the YAN, and you got your IP address, and you can do some configuration there. And you can also upload sketches on the YAN, and you can also install programs. And actually, to install programs, you need an SD card because Node libraries are rather big. So you copy it with SSH, or you let it install there. Let's look how this works. The YAN has actually, it's powered by a bridge. So you got two things. One, it's the Arduino board, which is this Atmega microprocessor. It's this one. And the bridge then sends and receives things from the network, either from Wi-Fi or Ethernet. And this is actually powered by a mobile Linux environment. And the fun thing about the Arduino 2, this can act as a web server. So you can then, if you have maybe a lamp, you could connect it and you could speak with your lamp, with your mobile phone, and switch it on and off if you, for basic thing. Or you could control a robot with. With the Arduino meetup, we have one guy who made a robot and he can control it with his mobile phone. And a small detail on the Linux part, it's driven by a Linino project, and it's focusing on bringing Node to embedded systems. Okay, this is the YAN, and without too much work, it would be difficult to work with Node. But there's another Node library which helps a lot with this. This is Cylon, and because I can show you. Yeah, we have already 3 devices laying around here, and it's expected. Yeah, there's another one coming later, and then there are the smaller ones, and they all need control things. They all need code to know how to behave and what to do. And Cylon is focusing on making this an abstraction layer about all these devices. And it's quite fun because it also supports drones. And if you ever get the chance to see a talk by them, they have even drones on robots flying in the room, and all controlled then by JavaScript. And yeah, for this talk, the Node, I tried the Arduino and the YAN part, and this is how Cylon code looks like. It's you basically define a robot, how it's connected, and the robot has a work function, and the work function does and stuff, and there you put your interaction, and you can let the device run. So you don't think anymore as a board, but it's a small robot then. So that's the basic idea. Okay. Then it's still another way to talk with JavaScript to embedded devices, and there's this because all these approaches were actually hacks. And there's one team working on a device which understands JavaScript natively, and this is Tessel. And here you can push JavaScript really to the device, and it can interpret it. And they do it like the following. They have you push a JavaScript file, and it's transpiled to Lua, and Lua it's then executing the code. And this is what they are working on right now, so that it's even going faster and it's more compact to work with. I can show you an example of blinking again with Tessel if it's fun. But okay, the main messages I wanted to tell you, it's about physical JavaScript is fun, and there are some hiccups, but it's still, I think, it's really changing the way we look at information and maybe at computers. And we see dedicated embedded systems. I'm just started a blog on these embedded devices, and I also want to invite the people who think it's interesting to have a look at Munich Arduino meetup. We have regular meetups, and yeah, we're in contact with the Maker Labs, like Fab Lab and Munich Maker Lab, and yeah, it's more like hacking then. It's less about talks, but more bring components and maybe try to discuss how a sensor works, or how to how to make something work, and because I think this interaction is really fun about these embedded devices. Okay, that's it for me. I was very fast. Let's see.